In this session, let us solve some problems on sequence impedances of transmission line. Okay, the parameters of transposed overhead transmission line are XS value they have given, XM value they have given, XS as 0.4, XM as 0.1, the positive sequence X1 and zero sequence reactance X0 are respectively. Okay, so what was XS? Like X1 positive sequence reactance is going to be XS minus XM equal to negative sequence. In the transmission line we discussed. And for example, if you think of X0 is going to be XS plus 2XM. Okay, so he is asking positive sequence. Positive sequence is XS minus XM. 0.4 minus 0.1 is going to 0.3. And X0 is going to be XS plus 2XM. 0.4 plus 2 into 0.1 is going to be 0.2 plus 0.4 is going to be 0.6. Okay, so 0.3 and 0.6. Now let us solve one more problem. The series impedance matrix of a short three-phase transmission line. Why they said short? Because they are saying short such that they are not considering capacitance indirectly. They are saying that's it. Okay. In phase coordinates, if positive sequence impedance is 1 plus J10 and zero sequence impedance is 4 plus J31, then the imaginary part of Zm is, in the sense XM is. Okay. So what is positive sequence? Positive sequence is going to be XS minus XM and zero sequence is going to be XS plus 2XM. Okay, so what is X1, X0 here? X0 is 31. Okay, so XS plus 2XM is going to be 31 and XS minus XM is going to be 10. Okay, only imaginary parts I am considering. So this minus this cancel, minus of minus will be plus, this is going to minus 3XM equal to 21. So XM is going to be 7, 21 by 3. So XM value, Zm value, imaginary part of Zm they asked, so that is nothing but XM, that is nothing but 7. Now let us solve one more problem. Don't get tensed by seeing the length of the problem. Okay, so suppose we define a sequence transformation between ABC phase sequence ABC to PNO, in this as positive, negative, zero sequence. Variables as follows, where alpha is 1 at an angle 120 degrees or e to the power of j 2 pi by 3, k is a constant. If it is given that this is given, they are asking z. Okay, see here ABC phase sequence, in the sense functions of ABC, and they have got some constant and this, and positive, negative, zero sequence functions. Okay, now here positive sequence, negative sequence, zero sequence is going to be sequence impedance multiplied by positive, negative, zero sequence current. Okay, such that positive sequence current is going to be positive sequence reactance into positive sequence current. Negative sequence voltage is going to be negative sequence reactance multiplied by negative sequence current. Okay, now let us see A, B, C, and they are asking Z, IA, IB, IC. Okay, so what this Z would be? Z would be ZS, ZM, 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 ZS, ZM, and ZM, ZM, ZS. For the transmission line we have seen in our previous discussion. Okay, so means with respect to, for example, phase A, self will be there, mutual will be with respect to B and C. With respect to, if I think of phase B, with respect to A, mutual will be there, with respect to B, self will be there, and with respect to C, mutual will be there. That's it. Okay, now what is this? This is going to be diagonal matrix. Okay, so positive sequence, negative sequence, zero sequence. So what is positive sequence? X1 is going to be 0.5, is nothing but X2 transmission line, and X0 is going to be 2. Okay, so what is X0 here? X0 zero sequence is nothing but XS plus 2XM. Okay, so is going to be how much? 2. Now what is what do you say? X1 here, XS minus XM is how much? 0.5. Now negate this. This will get cancelled. Minus of minus will be plus. So 3XM equal to 1.5. 2 minus 0.5, 1.5. So how much is XM value? Is going to be 1.5 by 3 is going to be 0.5. Okay. So if XM is 0.5, how much will be XS? XS equal to 0.5 plus XM is going to be XS value is going to be 1. Okay. So what is my this network now? My network is going to be self, mutual, mutual. Self is going to be 1, mutual is going to 0.5, mutual is going to 0.5, mutual 0.5, self 1, mutual 0.5, 0.5, 0.5, 1. That's it. Now let us think of one more problem. Okay, these are all actually small problems. Okay, now a three-phase transmission line shown in given figure. Voltage drop across transmission line is given by the following equation: self, mutual, 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 self, mutual, 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 self, as usual. And shunt capacitance of the line can be neglected if the line has positive sequence impedance of 15 ohms and zero sequence impedance of 48 ohm. Then the value of ZS and ZM, same thing. Okay, so what is zero sequence? For example, zero sequence is going to be self plus 2 times mutual is going to be how much? 48. And x1 or x2 is going to be 15. What is this? xs minus xm is going to be 15. Okay, so this minus this, 3xm equal to 48 minus 15 is going to be 33. So how much is xm? 33 by 3 is going to be 11. Okay, if xm is 11, xs is going to be 15 plus 11, so 16, 26. So xs is going to be 15 plus 11, 26. Okay, so zs value is going to be 26, zm value is going to be 11. Okay, basically in sequence impedance of transmission line, very small questions will come. We need not revise or we need not remember multiple things.